Dr. Bean has won the Nobel Prize for solving the mind-body problem through successful macroscopic quantum teleportation.
I have a question for Dr. Bean. Dr. Bean, does your experiment succeed in proving your theory true, or does it fail to falsify it? Dr. Phat is an associate professor of physics at Soka University of America. He has brought thinkers like Brian Greene to campus, creating rare moments where students can directly engage with some of the most inspiring minds in science. A graduate of Williams College with a PhD from Cornell, Dr. Wu has spent more than 25 years helping students emphasize the bigger picture and pursue the interconnectedness of reality through his award-winning courses curated for students of varying backgrounds, interests, and levels. Today, he is going to reveal to us the essence of how physics as a field works, as well as clearing common misconceptions about its intent and scope. Join me in welcoming Dr. Phat.
Physics has been something that I have tried to pursue since the time I watched Interstellar. I remember the next day going to my library and asking my librarian to teach me physics because that is what I thought physics was, Interstellar, and I couldn't understand anything when I watched the movie. I was in sixth grade, and what she gave me was a book of Newtonian mechanics, and I was like, how is this F is equal to ma and all these things related to that black hole that I saw? So that huge gap is what led me to understand physics, and I wanted to understand your story. How did you become a physicist? What's your story?
Yeah, so ever since I was little, I was, just in love with knowledge, right? So it really didn't matter what kind of knowledge, I was just interested in it. So when I was little, if you asked me what I wanted to become, it would be a list of 20 different things, right? And I couldn't choose among any of them. Um, so in college, why did I decide to major in physics? So, um, well, I was good in math and I was good in physics. Maybe I was even better at math because in some sense I got good grades in math without trying too hard. But with physics, I still had to try try hard. Um, but what I discovered in college was that I loved my poetry and my music classes way more. uh, but there was a practical part of me that said, okay, but science is more concrete, so probably it's easier to get a job in science. So instead of switching majors or anything, I continued to major in physics. I'm sure there was an ego component to it as well, right? Which is, oh, I'm doing something hard. Other people think physics is hard, whatever, right? So, um, but uh, but I didn't fall in love with physics during this time, right? So I think part of the problem was that, if you choose a major, I think your teachers assume, well, you're already interested in this topic. I don't need to get you interested in this topic. I just need to teach you the material, right? Um, so in that sense, they never taught it in a way that made me like fall in love with physics. I think they already assumed, they don't, that students are interested. So there was nothing that they did that made me fall in love with physics. And so here it is, graduation. When you graduate from Williams College, you know, with good grades in physics, apparently they offer you jobs at a bank with a lot of money without you ever applying, because that's what happened to me. I got an offer to work at a bank. I never interviewed, and here's the offer. Of course, I don't know anything about banks, but whatever bias I had about working at a bank at the time made me reject that. Okay, so not because I knew anything about banks or anything like that. I just, I don't want to do this. Um, and I felt like I didn't apply to any other job either. So I applied to grad school because that was familiar to me. Let's apply to grad school. And I wasn't sure I wanted to be in physics, so I said to myself, I'll apply to the top 10 physics schools. And if I don't get in, well, that's a sign. I'll do something else. So I got into some of those and went to Cornell, and in the first year was a teaching assistant. And it was being a teaching assistant and taking care to do a good job that I began to fall in love with physics, because I was thinking, well, how do I make this interesting to the students? Really made interesting to me And trying to figure that out, uh, I started to see things in physics that my professors never told me, and I started to fall in love with it. By the way, I want to share with you and people watching this. There's this quote. I forget who said it, but basically the quote is, "I don't take care of my children because I love them. I love them because I take care of them." Right. So the idea that you don't fall in love, you can fall in love right away, right? So I could have fallen in love with physics right away, like maybe you did. Um, but the other thing can happen, which is that you fall by taking care to do a good job, you fall in love later, right? Love comes later at the end of taking care, right? So, and I think that's true for a lot of things in my life uh, that have lasted, which is I fell in love with it later after a process of taking care, right? Versus love at first sight, which sometimes that doesn't last. Right? So that's what happened in physics. I have a deep attachment to physics now because of the process of falling in love with it slowly over time, and uh, and that's really stuck with me. Yeah.
Wonderful, sir. That's really interesting. Part of the reason why I fell in love with physics initially was the kind of expectation that physics is something that will lead me to truth. And before I try to understand this relationship between physics and truth, I want to understand your opinion on this notion of truth. It is very alluring because many people have this kind of an idea that there's a truth. And I was wondering if truth as a notion refers to something that is singular, or can there be multiple truths? And is truth, if at all it exists in any form, is it something that we can look forward to knowing by defining it in any minimal sense?
I think there's some minimal sense in which we can talk about truth, but then in the maximal sense, I mean, all bets are off. I love that you use the word alluring because within that word is the word lure, Lure. Allure. An example of a lure is like a fish bait. You have a hook, you got a fish bait, and you're dangling it. It's a lure to get fish to come, and you know they're in for a surprise if they think this is truth. Okay, so I love that you use the word alluring for that because in a way that's how I view it. It's a lure, but it's not. Things aren't going to turn out well. just like the fish. Okay, so um, well, let's talk about it in some. Well, first of all, why is it alluring? And so I'll talk about it in kind of a common sense first, a couple of ways, and then maybe we'll move on to the larger aspect of it. First of all, you can't succeed in anything if you don't know the truth. Okay, if I want to be a good teacher, I better know the truth about teaching and learning. If I want to be a good parent, I better know the truth about being a good parent, which includes nutrition, encouragement and punishment, various things about that. If I want to be a doctor, I need to know the truth about that, right? So you actually, if you want to be a good student, you also need to know about the truth about how you study, how you manage time, all this kind of stuff. So you can't really succeed in anything unless you know the truth. And this is why I want to emphasize this is that in my own personal life, I saw that our social reality keeps us so busy that we don't have time to reflect on that aspect of truth. So you're busy doing various things throughout your day, but you don't make sure to stop and say, what's the truth of today? What's the truth in what I'm doing? Because when you stop to do that, you realize, oh my goodness, you're ignoring the truth, and therefore your day is not as optimal, effective as it could be, right? Um, and sometimes, quite frankly, we ignore the truth because the truth of some truth is that the truth is painful. So in a lot of ways, sometimes we avoid the truth because it's painful. We gravitate toward truths that are comforting, but they're not really the truth, right? So I think in a lot of our lives, we're not paying enough attention to the truth, and therefore, um, paying the consequences of that. But in terms of truth that we possess, um, I would separate out at least two kinds of truth, right? There's something I would call phenomenal truth versus something I would call narrative truth. Okay. Phenomenal truth are things that fall within our senses. We can see, hear, touch, etc. Right? So, for instance, I see that the shirt you're wearing is of a particular color, um, and other people will agree with that as well, right? So uh, so we have a truth called phenomenal truth that's usually objective because you can get other people to agree with that, unless they have a medical condition, something wrong with their brain or something like that. Um, Usually other people will agree with it, so in some sense it's objective, right? And then there's something called narrative truth, which are things beyond human sense perception, and so we're just guessing at it, right? So, for instance, in the ancient times, the Greeks saw that the sun is moving in the sky. They can see the sun moving in the sky, but they can't see what's causing that. Okay, so they make up a narrative about how there's a god Apollo and so on and so forth. Okay, so narrative truth are stories that we make up about things that we can't see, touch, or feel, can't hear, that don't fall within our sensory perception. Um, but even the truth of phenomenal truth is not true. Okay, so here we start to get deeper into your question. Now, phenomenal truth, for instance, look, I can get I can get a lot of people agree with me that the Earth is not moving. Right? So it's objective. Lots of people agree with it, right? I can even have reasoning about it. Like if the Earth was moving, if I jump up, I should land in a different spot. Okay. So anyway, so all of that is within our sensory perception, and therefore and shared by other people who can sense those things as well. But it turns out even that is not a guarantee of the truth, right? Because it turns out that's false. This idea that the Earth is not moving, right? So so this is rough. Okay, so um, I started off saying, yeah, we have truth we possess. It's called phenomenal truth. But yet, if you look carefully at phenomenal truth, you realize, oh wow, phenomenal truth also is kind of uncertain and possibly wrong. And that's interestingly, that's connected to narrative truth. So maybe we'll talk about that a little more. But to the other parts of your question, does it exist? Is it singular? Is it multiple? Again, it depends on the context in which I want to answer that, right? And I can use metaphors to kind of answer that, right? So one of my favorite metaphors is that of the cone. If the truth is a cone, right? If we as human beings are limited in our perception, then maybe we perceive the cone as a circle, or we perceive the cone as a triangle, right? But we never see the cone as it is. So in that sense, truth is partial, right? Or truth has different vantage points. So if you look at it one way, it looks like a circle. If you look at it in another way, it looks like a right. Um, uh, but then to go even further, I'm now thinking of the Hindu texts, right? Because Hindu texts, you're talking about nirvana, you're talking about the Atman being one with the Brahman. I mean, the goal is to experience infinite joy, infinite knowledge, infinite being. But then you think about math and you realize, well, wait a minute, there's different kinds of infinities. There are infinities that are smaller than other infinities. So what infinity are we talking about in Hinduism, right? So and does it allow for bigger infinities, right? And things like that. Um, so kind of circling back and then allowing you to kind of jump in because I don't want to talk too long about this. I want to respond more directly to your questions. Part of this is kind of reminding us of where we are, our place in the universe, right? Because even with our sense perception, I can make the argument that we sense almost close to 0% of reality, right? Just take color. we see red to violet, we actually don't even see an infinity of colors within that range. We only see certain, you know, sections of red to violet. But to the left of red is infrared and an infinity of colors that we can't see. And to the right of violet, we have ultraviolet and an infinity of colors that we can't see. So based on all the colors that we can see and the small amount that we do see, well, that fraction is almost 0%, right? Same thing with smell, same thing with hearing. Right now, there are insects tapping, on the leaves and communicating with each other in a frequency that we can't hear. So there's, but there are certain frequencies that dogs hear that we can't hear. So you talk about all of our senses, and really, we only sense a very tiny, tiny fraction of what's out there. We perceive that the Earth is moving, but the Earth is not moving, and that's wrong. We perceive that space and time is a particular way, but turns out that's wrong. So for a life form that is that faulty in its perception, why have the expectation that we have truth, right? Um, anyway, as we talk on, I'll bring out other aspects of this, which is that what works is not what was true, and how do we prove something is true, and that kind of thing. But please jump in with another question.
Sure. Just to highlight one point that you said, that we phenomenally we perceive that the Earth is not moving, because there can be many arguments for it. You can reason it out. Um, but does that mean that the fact that it is moving is true if this is false?
Well, again, we can't. So this goes at the heart of, can you prove something true? Okay. And the human arena, the human endeavor that should be the best at proving something true is physics. Okay. Physics is the most precise of all the sciences, right? So science in general, you can is an excellent venue for proving something, right? But it turns out, and this I'm really borrowing from Karl Popper, the philosopher of science. It turns out the method of science actually can't prove anything true. It can prove things wrong very, very definitively. Okay, but it can't actually prove something true. So when you do an experiment and you say, "Oh, we confirmed our theory," okay, we have to unpack what the word "confirm" means. What you confirmed is you confirmed a prediction of the theory. You confirmed that you were unable to falsify your theory. Okay, but you did not confirm that the theory is true. Okay, so we've had many examples in the history of physics about this. Right? We've had theories that lasted for 100 years, for 1,000 years, for whatever, that actually turn out later to be proven wrong. So all of those experiments that confirmed it for 100 years, right? All they did was fail to confirm that was wrong. Okay, so it wasn't that it was true for 100 years; it was wrong the whole time. We just didn't know it. Okay, we didn't have the ability, the knowledge, the understanding to be able to finally prove it wrong, right? So, but the theory work. Okay, the theories work. Okay, so that's I can prove Newton's theory is wrong, but well, the theory still works, so I use it. We use the theory to send satellites into space, to send people to the moon, and so on, because it works. But it's not true because I can prove that the narrative of it is wrong. And the way I prove that is the theory makes a certain prediction about a number, and I can show through appropriate precision that what the theory predicts, what Newton's theory predicts, is different from what the theory predicts, and therefore the theory is wrong. Okay, so, but it works because when humans use numbers, we only need, for building a building, we only need to a certain decimal place. For sending somebody to the moon, we only need precision to a certain decimal place, right? And so even though the theory is wrong, if it's right to that decimal place, it works. Okay. I should say, if it works to that decimal place, it works. But it doesn't work to another decimal place. That's why it's wrong, right? So, right. So um, that's an answer to your prompt.
Sure, I mean, that's a good segue to the next question because you mentioned physics theories. So, for centuries, like physicists have kind of tried to describe what the universe really is. And there are several theories that have come out of it. Newton described a mechanical universe with absolute space and time where gravity was thought to be a force. Then Maxwell revealed that the universe isn't empty, but filled with invisible and continuous fields. Einstein's special relativity then fused space and time into a connected fabric, showing that motion and time depend on how fast you move. And also, special relativity favors this idea of a deterministic structure where everything that happens has already occurred in a block universe and it is just manifesting forward. With general relativity, Einstein went further. He said that gravity wasn't even a force, but the bending of this very space time fabric. Matter tells space time how to curve, and space time tells other matter like how to move accordingly. So, but however, quantum mechanics, it completely overturned determinism by showing that reality is governed by probabilities, wherein objects exist as superpositions until observed. Quantum gravity now, it treats space-time itself as quantized, and string theory extends this idea, proposing that all particles and forces arise out of vibrations of tiny strings. Space-time itself, in this case, is not fundamental. It emerges as from a collective behavior of strings and branes in higher dimensions. On the other hand, we have this holographic principle that proposes that the universe may be a hologram. Everything inside is encoded like information on its boundary surface. And more recently, I've also come across this theory of conscious agents. It takes a step beyond matter and space time again, suggesting that consciousness itself is fundamental, and what we call physical reality is just an interface generated by interacting minds. So now, when these theories, when you kind of come across, you realize that these are very, very different from each other. Yet, what they're trying to explain is the existence, is the universe. So, what is the reason behind these theories being so different in terms of how they explain the reality?
Right. So the first answer is that these different theories are looking at different parts of reality, right? So, you know, relativity is about the large scale of the cosmos, and stars and planets. Quantum mechanics is about the very teeny tiny parts of reality, right? Small inside atoms and so on. So you can come up with different theories that work in different contexts. You can do that. Um, uh, the deeper question, which we can talk about in more detail later, is can you come up with a coherent story that works across all these time scales and all these distance scales, right? And that's the goal of physics, is to have a single coherent story, not a patchwork of theories that work in different contexts and different arenas, but they don't work well with each other, right? So that's one. That's historically what accounts for the variety. But the deeper reason why you have, I think, different stories has to do with something that I term the uncaused cost. Okay, so this is going to take a little bit of time, but let me start with the theory of conscious agents. I don't know if you're aware, but I'm at Soka University. UCI is nearby. Donald Hoffman, who works on the theory of conscious agents, uh, a math professor here at Soka, and myself did work with him for about a year on that. Yeah. Um, and because we were interested in some of the mathematical foundations of that. But I have to confess with you that I became disappointed fairly soon. Not because this theory isn't worth pursuing, right? Um, I feel like any narrative, any theory people have is worth pursuing because eventually it might produce something interesting. So to me, there's no narrative, there's no theory that will ever, in my mind, be true. Okay, and I can explain why that is. But you still should pursue them anyway, because what happens when you pursue narrative truth is that you generate new phenomenal truth that you did not see before, right? So the metaphor would be like narrative truth is a horizon, right? You walk towards the horizon, but you never get closer. Okay. Then why walk towards the horizon? Well, you walk towards the horizon because you see a new landscape and old landscape disappear. So the pursuit of narrative truth won't end, but the pursuit of it yields new phenomenal truth. That's progress, and gets rid of things that you thought were phenomenally true, but now is shown to be wrong, right? So that's also progress, right? Um, so back to what I was disappointed in. Well, when you look at the math, okay, and again, I think this will be related to other things we'll discuss today. When you look at the math of the theory of conscious agents, guess what? There's an uncaused cause. Okay. And before I use it to illustrate the uncaused cause, let me explain what the uncaused cause is. Okay. So if a cause has so a cause can be an effect of a previous cause, right? So 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 if a cause is caused by something else, that cause is not uncaused because it's caused by something else. So the question is this caused by something else? If it is caused by something else, then it's not an uncaused cause. You keep going back. The uncaused cause is a thing where you're like right now you don't know what caused it. Okay, so that's an uncaused cause. Okay. What I don't like about the uncaused cause, and I see all kinds of problems coming out of it, is because this cause now is uncaused. It's not restricted by anything. Okay. Because it's not restricted by anything, you can come up with anything you want, right, to explain this. You want this to be caused, right? So you want to come up with something that will cause this because you want to understand where did this come from. Well, you can come up with something to explain this, so this is no longer the uncaused cause, right? But now this thing that you just came up with is uncaused. Because it's uncaused, it's not constrained or restricted by anything. This thing. So it's a free parameter. Okay. It's a free parameter. Well, give me enough time and give me some money. Okay. So and I'll find something that will explain this. Okay. And so I'll go through several examples of that. So one is the theory of conscious agents. Well, in the math, the fundamental math of it, you have these mathematical symbols. Well, what are they? Well, in the theory of conscious agents, he calls them conscious agents. Well, why? Right? Because because in other theories, guess what we call these things? We call them particles. We call them fields. Excitations of fields, right? Well, why did we call them that there? Right? Right. So it's kind of arbitrary, right? So it's kind of arbitrary what we choose to call these things because there's nothing that constrains our choice of what to call them. Sure, I can call them material things like particles, or I can call them, conscious agents, right? But there's nothing prevents me from doing anything I want just because of, I want it to be that way, right? So that's kind of the caveat that I want to point out to people about the uncaused cause. So here's some other examples. In the old days, they thought the Earth was at the center and the planets went around the Earth. So in order to predict the phenomenal truth that Mars will be at a certain place among the background stars at 2 a.m., right? They had to make Mars use like all these different loops. Instead of being traveling in an ellipse or something, they had Mars doing some crazy motion. Okay. And that crazy motion, that theory predicted where Mars is going to be, or can predict where Mars is going to be at 2 a.m. on a particular night. Okay. And if they did better measurements and it didn't work as well as before, they could change the motion of Mars so that it will fit. So because what the motion of Mars is an uncaused cause. So I can change it however I want. It's a free parameter. I can change it however I want so that it works out the way I want it to work out. Okay. And of course, as we know, the fact that we get something to work out as we want it to work out does not mean that your theory is true. So in the case of the geocentric model, the Ptolemaic model for the heavens, it was falsified eventually, right? And how about string theory, right? So string theory, one of the things that string theory is trying to explain, there's roughly like 20 fundamental constants of the universe, right? That's at the level of uncaused causes, right? Because if these numbers change, everything about our reality changes, right? So it's at a high level of causation. So what caused these constants to be their value? Okay, so I have to come up with an uncaused cause that causes this, right? So the uncaused cause for in string theory is the shape of the extra dimensions, right? Depending on the shape of the extra dimensions, it restricts how strings vibrate, and the restriction of how strings vibrate restricts the values of these fundamental constants. Okay. Well, yeah, if you give me all the freedom in the world to pick the right geometry shape, yeah, I can explain our world. Okay, but then why is our world this shape? So now I have to come up with an uncaused cause for this. But since it's uncaused, I'm completely free to choose what I want. And so, sure, give me time and money, and I'll be successful explaining why, you know, our universe is this particular shape. But then I have to go through that process again and again and again, right? And so, in doing this over and over again, our narratives change, our theories change, um, and so that's why we end up with a new narrative, and then depending how smart we are, that narrative might last for 100 years or 1,000 years, but eventually we have to discard that one for another one. Because and why would we expect anything else? Why would we expect to arrive at the truth? A 0%, an almost 0% creature. this is a perfectly expected that we wouldn't have a good grasp on the truth, because we're clearly not the highest life form. We're not even, I don't know where we are, but we're close to 0%, right? So just on that standard alone, we're not like the most amazing life form there is in the world. So our grasp on the truth it should not be surprising that we have a very, very little grasp on truth.
Okay. There are some couple of very interesting points that I thought I needed to little probe deeper on. First of all, when you said that these theories explain different parts of reality, definitely. But in a later question, I'll perhaps come to the point in which there is a common phenomena that two theories seem to describe differently, and therefore that's kind of the conflict over there. But I'll come to that later. This aspect of the free parameter and the uncaused cause, you did highlight it for the string theory, but could you give a little more examples of the theories that I mentioned, and what the adjustable or free parameters or uncaused cause in those theories, like Newtonian mechanics, like?
And so, for instance, uh, take Newton's theory. Okay, so Newton's theory of gravity. Now, in physics theories, we would like our theories not to have free parameters. Okay, if possible. But even when our theory explicitly doesn't have free parameters, they have hidden free parameters, right? So the free parameters in Newton's theory is, the gravitational constant g, the mass, the initial conditions, whatever. Um, uh, but there are some hidden ones, right? Which is what's your choice of space and time? We have freedom to choose what space and time is. It's hidden because Newton assumed that there was no choice. Well, it turned out there is a choice about how we choose what space and time is. So Newton by default chose that space is flat and time is flat. Right? So, right, a space time that's flat, right? That's like a stage where everything acts on, right? Because he thought that, well, that's obvious. We don't have a choice in the matter. But it turns out, no, that's not obvious. What is space and time, right? And so when we make our theories, we can choose what is space and time in this theory, right? In general relativity, we choose space and time to be connected, right? Through the speed of light. We choose space and time to be dynamic, which is interacting with matter, which is through the gravitational constant g, right? But in quantum mechanics, we choose uh, space and time to be quantized, right? And in string theory, we choose space and time to be 11 dimensional. Okay. In you know in where modern physics or contemporary physics is heading is thinking of space and time not as fundamental but as emergent from information, right? So time is the unfolding of information, space is like an entanglement of information, that kind of thing. But my point is that even when you can come up with a theory that supposedly has no free parameters, explicit free parameters, there are assumptions in the theory, right, that are hidden. It turns out when you come up with a new theory, those hidden assumptions are made more explicit because you're trying to explain them. But then your new theory now has other hidden assumptions, right? So yeah, it's just that's a human condition. I'm trying to emphasize for you that we're human, and part of the human condition is infinite regress. Right? So, which is we can't get rid of the uncaused cause. Because we're human, we perceive almost 0% of reality. So when we pursue narrative truth, we're unlikely to get there. Okay, but it's worth the journey because we see new landscape and old landscape disappearing. Yeah.
I see. So when you mention this example that we see the sun rising, but over a period of time we were able to falsify that phenomenal truth because at a particular time, from what we saw, the sun is rising, but later from what we saw, it was not what was rising particularly. So that is a falsified phenomenal truth. So
Yeah.
there is a sense, as humanity has evolved, as physics and science has evolved, there is a sense of extending this what seemingly is part of our sense perception and therefore phenomenal truth. So how do we extend when you talked about the 0% perception of reality? Of course, there are things that in the visible spectrum I can see limited amount of frequencies, but through different devices I'm able to expand on that. I'm able to see
Yeah, the
more than those frequencies.
infrared goggles. Yeah.
Absolutely.
Or like
So
other kinds of paints that will reveal ultraviolet light, for example.
yeah. So these are ways in which we have tried to expand our perception. And so in physics, exactly how do we, what are the various ways in which we try to expand this limited perception to be able to falsify certain phenomenal truths and go ahead in that direction, if not?
The answer is math. There's two parts to my answer, I think, which is the real answer of expanding human perception is math. I would say that's my main answer. But the other part of my answer is what are experiments really doing, right? So maybe we'll tackle that one later. Um, but let me talk now about the first part of the answer, which is it's really math that does it, right? So I think of math as a transcendental tool, and I define transcendence this way: um, by ourselves, we would never have known this, right? Right? By ourselves, we would never have known this thing. Okay. So if something allows us to know something that by ourselves we would not know, then to me that's a transcendental tool. Okay. So math has shown itself to be amazing at revealing things that we would not have known to look for even, right? We didn't even know it was there, right? So some examples are, math allowed us to figure out a mathematical theory that says, oh, the Earth is moving, and if you could do this, which is look at uh, the phases of Venus, right? Then you can prove that the Earth is, or at least you can falsify the geocentric model and confirm. Again, confirm here means something different. Confirm the sun-centered model. Okay. Math has shown, for instance, when Einstein discovered E equals mc squared, he didn't sit down and say, I'm going to find the connection between energy and matter and the speed of light. He didn't do that. He was working on some other problem. Okay. But the mathematical logic spat out E equals mc squared. And when he saw it, he told his wife, the gods must be laughing at me. Because he thought, well, this equation can't be right, because this equation says that, this toothpick, if I can release the energy in it, is a bomb. Okay, so a very destructive bomb. And he's like, well, that's crazy. So I must have the gods are laughing at me because I must have done a mathematical mistake. Okay, right. So this deep unity between energy, matter, and the speed of light. Well, the math told us that. No human being imagined that. Okay. Math then, revealed a bunch of other things, including that, you know, you and I and, the glasses on my table, the TV, all of us have a deep connection to light because all of us move at the speed of light. Okay? And there's nothing you can do about that, right? So we all move at the speed of light through space time, right? And there's nothing we can do about it. What we can do is change our speed through space, which then changes our speed through time, because our speed through space plus our speed through time, geometrically added together, must equal the speed of light. Okay, and there's nothing we can do about that. That's a law. Right? So, and math revealed that, right? So I revere math because it has the ability to kind of, and I wish our educational system had told kids that in some ways, right? Because can you imagine if more people understood math to be this and was interested in using it to discover hidden secrets? Wow, we have a lot more people working on this and discovering more phenomenal truths, right? But no, it's not taught this way, and people don't see the importance of it, and unfortunately, people get turned off by math. You know, instead of being really interested in it and then working to be better at math. Yeah.
So when you say that the math reveals something, what is this? Because math as a transcendental tool, where does it exist by itself, or is it something that we invented out of our logical thought process?
Yeah, I'm not gonna claim to know anything about those mysteries, right? So I'll address it this way. We have so much inductive, vivid, tangible, concrete evidence that math predicts things that turns out to be phenomenally true, okay, uh, that we would not otherwise have known. That's just, I can, spend a lot of time giving evidence of that. Um, so that transcendental aspect of math, the way I define transcendence, is absolutely clear, right? Now, the problem though is, well, that's all the phenomenal part, right? Because yeah, E equals mc squared. Well, the phenomenal part of that is nuclear bombs and nuclear energy. Okay, so that we use that equation for that, right? So, um, but the part where it's less certain is the human part, right? Because when we interpret the math, right, and the mathematical theories, we end up describing the math in terms of human language and human concepts. And now remember, I said earlier, we're like 0% creatures or close to 0% creatures, right? In relation to the real whatever is out there, right? And so, given that human condition, if we're now trying to interpret math with almost close to 0% potential for language and potential for concepts, then it's not gonna work out very well. Right? So that's why we get things like wave particle duality. That's why we get things called superposition that we can't quite explain well, et cetera, et cetera. And that's why we have these narratives of all these different theories that you mentioned before, the holographic theory quantum mechanics and general relativity and quantum field theory and all these kinds of things is because the math is so capacious and so generous and so connected that you can connect, pretty much any part of math to a lot of other parts of math. And when you follow those connections, you're going to have a story to tell. Okay. And that story to tell is your narrative truth, right? But is that story correct, right? And and the evidence is no. Okay, now it might take a long time to prove a particular narrative, to falsify a particular narrative, but so far all narratives in physics have been falsified, and I don't see that stopping. So, and so the phenomenon is confirmed, right? So that's why we still use theories that we have falsified, but the theories are wrong. And really, the true source of that is because we're almost 0% creatures trying to shoehorn our language and our concepts into the math, into a human story. But the human story is in, is not big enough to explain that larger reality, right? So in a sense, the way what I do that to kind of say, yeah, it's a transcendental tool. Math is a transcendental tool, but we kind of mess it up by interpreting it in human terms, right? And so in that sense, it is uh, it is beyond math is beyond human. That the part where it's transcendental is beyond human, right? But the part where we then interpret it, we kind of bring it back down into the human cave, right? So math is a tool that gets get us out of Plato's cave, right? Okay, we're out of Plato's cave, but when we interpret that math, we basically construct a new cave, a larger cave that we're in, in a way.
But isn't it that interpretation that guides us to newer phenomenal truths? If we don't interpret it, how would we even know that what phenomena to test for?
That's why the reaction some people have to what I'm saying is, oh, then why bother? And that's the wrong reaction, right? Because yeah, it's precisely, that's why I say the horizon, right? Because if your goal is to get closer to the horizon, yeah, don't go to don't go to the horizon, okay? Don't walk to the horizon if your goal is to get closer, because that's not going to work. So if your goal in pursuing narrative truth is to get the final narrative truth, I'm sorry, that's my point of view is that that's never going to happen. And then you might say, well, then I'm not going to try to pursue narrative truth then. Well, no, the metaphor of the horizon is that, yeah, you don't get close to the horizon, but you want to do that anyway because now you see France and you never saw France before. So you see new landscape and it's exciting to see France. Okay, so and so yeah, we should continue to strive for narrative truth, to overthrow the previous narrative and come up with a new one, because there is a tangible, concrete thing that happens, which is we get new phenomenal truth. But I don't think getting a final theory is ever gonna happen. Yeah. Because of the uncaused cost. Yeah. And so in that sense, the the human possession of the real truth, whatever that is, I don't think that's possible. Yeah. Because so we don't have narrative truth. We kind of possess phenomenal truth, but if you look at it closely, even phenomenal truth is not true, right? So right, so yeah, but, truth is very much I think eluding humans. Yeah.
I'll get to that actually. Those that thing that you just mentioned, that even phenomenal truth itself. You gave an example of the rising sun, but I'll explore that based on what other theories say a little later. But I want to first dig a little more into the into math as a conception, meta conception. So you mentioned something very interesting, that math is interconnected. So, and that is true because if you see across theories, you get similar, so you get the same results actually if you follow different routes. Like Newton might have not followed a mathematical route to F is equal to ma, but a different mathematical route completely through calculus of variations leads to F is equal to ma for some optimized paths. Now, um, when you rank theories, you perhaps do that based on, as you said, the decimal place to which the precision of a particular theoretical prediction is. And that is with respect to what you want to make out of it. Like if you want to do something, you need a precision up to a decimal place. But apart from that, in terms of a hierarchy of theories, if you want to do it in terms of prediction of phenomenal truth, why is that one more decimal place necessarily a qualification for a theory to be better? Because you might not even have anything to compare the decimal place to know whether that progress is itself correct or wrong. So why is the decimal place and how necessary to progress or kind of make a hierarchy of theories, and what does it mean in terms of narrative truth?
Yeah. So the decimal place really is just whatever current narrative we have, we eventually prove it wrong at some decimal place. Right? That's what the decimal place is. The decimal place represents this decimal place is where we proved our theory wrong. Okay. So now we need to come up with a better theory, right? And that better theory explains what the previous theory explained, and now also explains where it went wrong, right? So that particular experiment, that particular prediction, it went wrong at this decimal place. So the better theory will now explain what will be a theory that is consistent with that decimal place, right? So in terms of hierarchy, that next theory is better because it could explain all the previous things and the thing that went wrong with the previous theory. So it includes everything that the previous theory did right or that worked, and it also contains what the previous theory did wrong. Okay, so in that sense, it's better, but it's not better in a human use sense, right? So Einstein's theory of general relativity is more precise than Newton's theory. Okay, uh, but you would never use it to uh, uh, construct a building or send somebody to the moon. Okay, Newton's theory is better. Okay, right? So that's a different kind of hierarchy, which is like in terms of human use, the ease of human use. It just simply depends on what's easier to use, right? But in terms of the hierarchy of can it do something that the previous theory can't do, yeah, then the later theories hierarchically are better theories. Yeah.
Okay, and when you say that there is a new math uh, kind of has a more precise predictions of phenomenal truth, um, but it tends to offer a completely different interpretation of reality when it comes to narrative truth, right? So you
Yeah.
gave the example of Newtonian mechanics and general relativity here. What they say is completely different,
Yeah.
but what is useful at different
Right.
times is depending upon the context and the scale you
Not
use that.
yeah.
So
So exactly.
yeah,
Yeah. So let me just focus on that. So a very tiny difference in number, right? A very tiny difference in number, can result in a hugely different narrative, right? So if you compare Newton's narrative of gravity to Einstein's narrative of gravity, which is based on a very small difference in number, right? It's completely different, right? Because Newton says we have flat space time. Things are forced to move in curves through flat space time by a force called gravity. Okay, that's the narrative. Okay, the narrative in Einstein is different because first in Newton's theory there's a force, right? In Einstein's theory there's no force. In Newton's theory space-time is flat. In Einstein's theory space-time is curved, right? In Newton's theory that force causes things to move in curves in flat space-time. In Einstein's theory there's no force. Okay, things move always in a straight line but through curved space-time. I mean, this is vastly different in terms of a narrative, right? The same thing with the geocentric model of the heavens versus the heliocentric model. because of a difference in number, you either have the Earth at the center or the Sun at the center. That's also different, right? So yeah, these small differences, right, are turn out to be quite powerful in terms of how different our narratives can be.
When the math is progressing towards these particular results, right? It tries to maintain consistency with the previous results for primitive scenarios and for advanced scenarios which the previous model could not reach. This is the one that tries to do so. At what point does the narrative diverge exactly when the mathematics is being pursued?
Yeah, so that's an interesting thing. Well, first, let me get back to back to what you said a while ago, which is, my metaphor of math as like a fully connected network. Right? Because those are the advances in math, that they show something in linear algebra is connected to differential equations, or something in algebra is connected to topology, or whatever, right? So math is like this infinitely connected network. But as humans, we don't see all of that. We see very little of that network, right? So we may, through our hard work, see that there's this particular connection through that network, and we call that a particular theory. Okay. And if we don't see any other path through that network, because we don't see it, we think, oh, we got the truth of uh, our theory is the truth. Okay. But it turns out later, again, through hard work, we're able to see more of this mathematical network, and we can travel a different path from A to B. And that different path is now our different narrative, our different theory for the phenomenon, right? Um, and so and so it's not that things are detached. Okay, I think because math, you can't really detach it from each other, right? So you can't really detach math. It's so fully connected, right? What happens instead is that we become aware. We discover a connection in math that we didn't see before, because this mathematical connection is represented by different structures and different symbols. It requires us to interpret it in human terms in a different way. You see what I mean, right? So before, in Newton's theory, it was, F equals G m1 m2 over r squared. Okay, and then we can interpret those things as, oh, there's a force, there's a distance between two planets, there's the mass of one planet and the mass of the other planet. Okay, but in Einstein's theory, right, you have these other things, right? Uh, this other mathematical way to kind of get to the law of gravity, and it involves complicated math, right? Behaving in complicated ways. And so now we can't interpret that anymore as, a simple force connecting two objects, right? Uh, we have to, in fact, um, use the narrative of curved space-time. Oh, by the way, let me backtrack, right? So this wasn't by accident, right? So let me trace how Einstein realized he needed to find other mathematical connections. Not that he had to, but that he wanted to. Okay, so let me kind of trace that. Um, all right, so Einstein, through special relativity, Einstein realized, okay, wait a minute, motion warps space and time, right? Because when you move, length contracts and time dilates. Okay, so motion contracts length, dilates time. So in a way, it warps space and time. Motion does, right? And then he had what he called the happiest thought of his life, right? He had this thought. He's like, I'm in an elevator and I feel heavier. Okay. Now, why did I feel heavy? Did I feel heavy because gravity increased? Or did I feel heavy because the elevator accelerated upward? By accelerating upward, it pushed against my feet, making my feet feel heavier, making me feel as if gravity increased. Okay. So other people would have just brushed this off. Well, that's an interesting coincidence, right? It's two different things causing the same effect, which is you feel heavier. But Einstein saw more in that. He's like, oh, wait a minute. Well, then does that mean, okay, so because those things are equivalent, right? Which is I feel heavier in both things. I know already that motion warps space and time. And if motion can reproduce the effect of gravity, then maybe gravity can warp space and time, right? So that was his thought. So he's like, okay, so I need to find a math so that I can prove that gravity is a warping of space and time, right? And it took him 10 years to kind of, develop the math and learn more about math so that he can come up with that, right? And ultimately that math is connected as an approximation. You can use that math and through approximations um, connect it to Newton's theory of gravity, right? So the math is not detached. What happens is that you discover that your current math, which has a particular narrative, is now connected to new math, and that new math requires you to come up with a completely different narrative, right? So the math is not detached. It's your explanation becomes detached in a way because it's you have to come up with an explanation for this new math.
Right, sir. But in this example that you gave, the narrative seemed to have come first and then a math to support it, right? Instead of the other way around.
Yeah, yeah, but it can happen the other way around too, right? So uh, I forgot how the Lagrangian was discovered, but you can imagine that it happened the other way around. Somebody just playing around with it, and whoops, through this particular path, you get F equals ma. Okay, so so this is another way to F equals ma, because before there was no derivation of it. He just simply said that, right? He just like, I'm going to experiment with some things, and I'm going to model it as F equals ma. Well, now you can, through the Lagrangian, you can get F equals ma, right? And now you got to interpret it now, and your interpretive is like, oh, it's the action the action needs to be stationary. Okay, so now your description of it just sounds different, and your description of it, by the way, now involves no forces. That's also very different, right? Because in the Lagrangian math, which is to calculate how something moves, right? You never ever have to talk about force, okay? Because you have a narrative of describing how it moves simply by discussing kinetic and potential energy, never having to talk about force. Whereas with F equals ma, you have to talk about force. Your narrative has to involve force.
Eventually, you do get to the force equals ma, so force does come about.
Yeah, because they're connected, right? Because they're
But
connected.
it doesn't come about as a narrative, is what you mean. It comes about only as a mathematical relationship, as a kind of an intersection point, mathematical intersection point. But it doesn't
Yeah.
depend upon the narrative of force, wherein from the
But
other.
look, but also look at the arbitrariness of this, the human being arbitrary, right? Because when we work with the Lagrangian and eventually get spit out F equals ma, we and suppose nobody thought about F equals, like Newton didn't exist. Okay, you have a Lagrangian and it spits out F equals ma. We could choose at that point to call the math a force. I labeled it, right, but that's kind of arbitrary, right? Because all along the way you had math, and you had at each moment in time an ability to call that math something. Okay, but you chose not to. We arbitrarily say, okay, well, there's all these mathematical manipulations. Here we'll call it the action. Here we'll call it the force. But we're not going to give it names. Any of the things in the middle. Okay. Uh, but that's arbitrary. Right? That's very, very arbitrary, right? So, but that tells you about the arbitrariness of narratives, right? Because we choose to say this is important, so we're going to give it a label, a concept, and a name, like dark matter, dark energy, whatever. Various things. Um, uh, but uh, you know, what about other things, right? So suppose I have A is equal to BC. Now I take the square root of A and I take the square root of BC. It's still equal. But me doing that the math doing that, does that represent something real in the world? If not our universe, does it represent something happening in some other universe? Right? So why? That's my question about math, right? Because we choose certain things to then say, oh, this represents the reality. But, but why do we pick out only these things to represent reality versus all the other mathematical manipulations?
Actually, that was exactly what I meant by the question. Because, for example, basically, at what point when you have a mathematical mesh like that in which things are intersecting, and you do make those intersections to prove the credibility of your mathematical route, to show that it is leading to the previous predictions and also more and more precisely, where are those turning points of narrative? Because, for example, you have this. Let's take a step further from general relativity. You have quantum field theory, which talks about gravity as exchange of particles of gravitons, right? And it too has the notion of space time. Yet the notion of space time is flat. It's not dynamic. It cannot. There is no curvature. There is no dilation.
That's
Yet
right.
it explains phenomena, and we'll get to that point in which it explains phenomena in a later question, like gravitational lensing, where you can explain through gravitons and through general relativity why such phenomena is happening, through completely different narratives, though in a completely different way. So it is also beyond the fact that the narratives are especially are specialized towards certain scales. They are they are kind of derived by the investigation of specific scales, but what they come about is a general narrative of the universe. So that's what I wanted to explore in a later question. But over here, I just wanted to confirm these turning points in which you start off a math, but you decide that, okay, I need space time though, but the conception of space time is not going to be dynamic. So this is a change in narrative, but there is a fundamental narrative that is still common. So what guides like these twig changes in narratives that come about? Is it because of these relations that you gave an example of A is equal to BC? So square root of A is equal to square root of BC. So these needs to have some
No,
physics.
I think it's simpler. It's simpler. What guides all of it is, does it work?
The narrative itself, deriving a narrative out of the math.
What guides all of it is, does it work? Because I want to take this particular maneuver in manipulation in math. Is it going to work? And what if, is it going to work means, is it going to work in terms of giving a coherent theory, in terms of giving a testable prediction, and then does it work because the prediction actually turns out to be true, right? Or true to some decimal place, right? Um, that's ultimately what guides it. And once it does those things, you can arbitrarily go back to it and say, I'm gonna call this section of the math something special, like superposition, or I'm gonna call this particular math something special, like the action, or I'm gonna call uh, blah blah blah, right? So the turning point of the narrative to me, um, you know, first you wouldn't give it a narrative at all if it didn't work, right? You'd just be like, okay, I played around with math, it didn't work, so I give it no names, no concepts, you know. Um, Now, of course, you might have a narrative in your mind. That's why you came up with playing around with that idea, right? You're like, oh, I'm gonna do string theory because I think the mathematics of strings, the zeta function, whatever, is very flexible, and so you have an idea already that there's a narrative for this math, which is strings or something, or vibrations or excitations or something. Um, and so sometimes it's like that. But if it goes nowhere, right? You're like, well, what does it matter what I call it? 'Cause it's not working, right? So, but when it does work, then it's like, okay, now I get to use the narrative I want, and focus and give terms to important parts of the math, like the commutation relations in quantum mechanics, or the rotation operator, or whatever it is, right? Um, uh, so you yourself choose these things. So I'm not sure that there's something at least I myself don't see something deep here in terms of your query about a turning point.
It is in terms of just to get clarity of how narrative and mathematics go together. How do they progress at the same time? So if you said it's a purely arbitrary function to ascribe narrative to certain parts of the math, so those part of the maths are foundational mathematically, but in order to explain what the math is, you kind of give a narrative. So that turning point, I'm trying to understand the pragmatism of it particularly. So you have this, you have space-time common in both general relativity and quantum field theory. The space-time is there, but the property of space-time is different. Here, if I try to prove time, let's say, in general relativity, that time does exist, it is true, it's not just entropy. I do give the experimental example of time dilation, right? But I explain it as a warping of space-time. When it comes to quantum field theory, I don't, the time space-time fabric is not dynamic, yet space-time itself is there. So I'm saying that when these different narratives come about because of different mathematical approaches, what are the variations in which that physics finds itself where narratives uh, follow the mathematics?
Yeah. So, well, first of all, as you were talking, I'll answer that in a moment. But as you were talking, I realized the more interesting turning point to me in the math is is when the math becomes something that you can narrate in a way that connects to phenomenal truth. Okay. Because there's clearly math that you're like, I don't know what this corresponds to in the real world. Okay. Which is superposition. Okay. Or the wave function in the Schrodinger equation. Okay. But if you multiply the wave, you square the wave function, which is to multiply by its complex conjugate, um, then it's now connected to something in the phenomenal world, which is probability. Okay, so I think there is a turning point, but the interesting turning point to me is when math becomes something that is interpretable in the real world, in our world, in the human world, versus something that I'm not sure what that is in the real world, and so I'll give it a name like superposition, but I have no idea what that is in the real world. I have an idea what it is mathematically because the math is right in front of me. Okay, but it doesn't have a meaning in the human world. Okay, so maybe we can return to that. But the other part of your question, which let's take time. Okay, um, so time. Okay, so time. At first, with the ancient Greeks, it was just something to keep track of motion. Okay, then time became assumed as a along with space as a stage in which things happen with Newton. Okay, but then time became in relativity, special relativity, time became something that was attached to space. Okay, and then it became something that was like a frozen river or a loaf of bread, which has existed by as a whole already. That past, present, and future were like past and future were illusions. All there is now, right? And that we conceive of time like we conceive of space. We walk through space, so we also walk through time. Before, time was something that flowed. The narrative was time something that flows. Now the narrative is time's a frozen river. It's not something that flows. It's something we walk through. Okay. Um, in quantum mechanics, you're right. Time now becomes like it's kind of went backwards, right? It's not some well in general relativity. First of all, time is not just something you walk through because you have mass. Your matter. So now you don't just walk through it. Your mass, your matter, your energy is dynamically interacting with time and warping it, right? So then when you get to quantum mechanics, strangely, time is like this external background clock keeping mechanism, which is odd, which is one of the clues that quantum mechanics can't be right or is incomplete because it treats time in this very kind of backward way, right? Uh, as a kind of a clock, external clock keeper. Um, uh, and then you go into, information theory, which is where modern contemporary physics is now, and time is now not something you walk through like it was in special relativity. Time is now, it's an unfolding of information. um, so those different narratives is just because we have different ways of modeling time now, right? That's all. The different connections to other kinds of math, the other mathematical ways of representing a previous thing, because that math is different, we now have a different narrative for it. So the turning point is just as simple as the math being different. Okay. But going back to the previous thing I said, which is the turning point that's interesting to me is when the math becomes something that we can say exists in our perception of reality versus math that doesn't exist in our perception of reality. Right? That's an interesting turning point. And maybe that's why, and maybe that's the reason why we usually don't name those intermediary mathematical steps. We only name the mathematical steps that connect to the real world or that are special in some way, right? So yeah. So superposition, I can use an example of the wave function and superposition. The wave function is complex, right? So the example I said of A is equal to B plus C. So suppose I multiply both sides by the square root of 1, which is I, the imaginary number. It's still an equality sign, so I did something absolutely legitimate mathematically. But before, when A equals B plus C may have had a human interpretation. Now that I've multiplied both sides by I square root minus 1, what's the human interpretation now? I don't know. Okay. So same thing with randomly taking the square root of both sides, or cubing both sides. I mean, I'm just doing things that are allowed mathematically, but what's the human interpretation, right? There isn't any. So same thing, the wave function in Schrodinger's equation is something in configuration space, whatever. So there's no interpretation in the real world, right? I can't use it to, to, to do something. But if I square it, then suddenly now it becomes a probability. It has information about the likelihood of something happening, right? Now, by the way, there are different versions of quantum mechanics, right, that will suppose the reality of the wave function, right? So, David Bohm's pilot wave theory, right, insists that particles are real and the pilot wave is real, and it's the pilot wave is somehow affecting how a real particle. So the particle really does go through one slit or the other, but it's the wave, which is also real, that's kind of um, affecting where the particle lands on the screen. So you see the uncaused cause there, right? Which is we're completely free to declare what we want to be real or not real, right?
Can you just expand on this example a little bit, just for the sake of the audience, so we understand exactly how you're relating it to?
I skipped over superposition. Right? So the canonical strangeness of quantum mechanics is explained by the double slit experiment, right? Which is you send a particle of light, you know, through double slits, okay, and you see these light landing in these bands, these zones, okay, and that's mysterious because there's nothing that a human can imagine that would explain why light separates into these bands, right? Because if the light only went through the left slit, then you should see only one band. We don't see that. So we ruled out that the particle of light went through the left slit. Okay. If particles of light went through the right slit only, then you would see a single band on the screen. But that's not what we see, so we can rule out that the light went through the right slit. If different particles of light went through different slits, then you should see two bands. We don't see two bands, so we ruled out that, well, it depends which one they go through, but they go in the aggregate, they go through both slits. So we ruled that out. If it didn't go through either slit, we would see no bands. Okay, but we don't see no bands, and so we ruled out that it didn't go through any of the slits. Well, that's it. I can't think of anything else. Okay, there's nothing else I can think of. So the results themselves don't correspond with anything that a human can imagine, right? So, but we can explain why it lines up in these bands by using something called the wave function. Okay, the wave function does not allow us um, to understand what's going through the slits, right? But it allows us mathematically to explain how, you know, a wave of superposition, right, can go through both slits and interfere, and that interference results in, different particles landing in the different bands. Okay, okay, and it's only by squaring that wave function that you get the prediction. Right? But the wave function itself, in the canonical interpretation of quantum mechanics, right, doesn't have a human interpretation. We can't picture something that right, because what we often call it a wave of probability, but not really, because the square of it is the wave of probability, right? But what's a wave of probability? It's just a mathematical object. It's not a physical thing that moves through space and time, right? Uh, so so but other theories, like, the Bohmian pilot wave theory, right? It's trying to interpret the math and create math that gives an interpretation that, the particles are real. They actually do go through the left or right slit. They interact with this pilot wave, and it's the interaction with the pilot wave that tells an actual particle of light what to do and where to land on the screen. Okay, yeah, but there are probably a dozen different narratives of quantum mechanics, you know, and they unfortunately, at this stage of our development, none of them can falsify the other, right? We don't, well, this is not surprising. At one moment, in most of our history, the geocentric model of the heavens and the heliocentric model also could exist side by side, because we did not have the knowledge to falsify either one of those, right? So both of them were good candidates for explaining how the heavens moved. Okay, here in quantum mechanics, we have all these experiments, but all these theories can explain these experiments. you know, so we don't know which one is eventually going to be false. With the geocentric model, eventually we prove that one false, right? But with these different quantum theories, we don't quite we're not at the stage of proving them wrong yet.
Interesting. So, just for clarity's sake, I want to now clearly differentiate between what is the narrative and what is phenomenal, just for the sake of definition. So, in this case, in the double slit experiment, what you observed, the fringes that you observed, that is phenomenal truth, because that is something I saw, that is happening every time. And the mathematics, it allows for that phenomenal truth in its own framework to be predicted. But why that is happening, or exactly the reason behind that prediction being true, is the narrative which we are not able to exactly point out, and we perhaps will never do, because it is always
Because science cannot do that, right? So your narrative makes a prediction that you can test. Okay, so you test it, and we call that confirmation of your theory if it turns out correct. But the meaning of confirmation is that you confirm that your experiment, through some precision, was consistent with what the theory predicted. That's what you confirmed. Okay. In the long term, what you really confirmed was that you didn't prove it wrong. Okay. I can show, it would be maybe not appropriate for me to spend time showing you logically why science in the Popperian view cannot prove narratives correct, cannot prove its own theory correct. But I don't have to, because I can use all of the physics theories that we have that were confirmed over and over again for 10 years, for 20 years, for 100 years, over and over again through precise experiments that then were then proven wrong, right? So all of the, just because, somebody won a Nobel Prize for detecting gravitational waves through experiment, did not mean that the narrative of gravitation of gravity was proven correct, because we've had this movie before in the history of physics, which is amazing experiments that supposedly prove the theory correct, but then it turns out it's wrong anyway. Right? So the mere fact of having a experiment turn out the way you want it to turn out doesn't guarantee anything, and we know that. I don't need to resort to logic, right? That's the inductive evidence in the history of physics.
What are the different ways in which experiments actually happen?
Um,
Like
so,
majorly, what are the
yes,
ways in which?
the key thing is that in physics, the key thing is that turn, which is the turning point, which is the complicated math that you did, right? Eventually predicts something that can be tested through human instruments. Okay, in that sense, our experiments don't really expand human perception, right? Because what the experiment really is doing is measuring things that humans can't perceive. Okay, because, and then psychologically, because our experiment turned out okay, we psychologically want to believe that the narrative is true. That's just a psychological thing. It's not a logical thing. It's not the correct thing. It's just a psychological thing. I did this experiment, which is in the realm of human perception. It proves the narrative. It's correlated to the narrative of things I can't see. So now I think that space actually is curved. Space time is curved. Okay, and so I think I've expanded human perception. No, because that theory, Einstein's theory, is going to be wrong, like all the other theories have been wrong, like all the other narratives have been wrong. Okay, so we don't actually, through experiments, actually expand human perception. What we expand is the number of phenomenal truths that's available to us. That's the expansion of human perception. Right? Measurements and our theories expand. Measurements and narrative truths, which are our theories, expand the number of phenomenal truths that we experience. That's what it expands. It does not expand humans experiencing things we can't experience.
That's very interesting, sir, because if you see, there are different kinds of experiments, right? Um, which are about things that we cannot perceive, trying to measure those things, but through things that we can perceive. So there is a kind of a different kind of experiments have different levels of narrative dependence. Or is it
Yeah.
that the narrative dependence is still same in all of them? For example, um, let's talk about different kinds of phenomenal truths. So what is phenomenal truth? From your definition, it is something that we can sense. So within my system right now, within the scope of what I can manipulate, I have this eraser, and if I just drop it, it falls, right? So this is a phenomena within the scope of what I can control right now, physically, and I sense that it fell. This is a phenomenal truth, right? But we don't know the narrative behind why it fell.
We're not even aware. My thing is that the human condition is that narratives are always present, whether or not we are aware of them.
Narratives are present.
Are always present. That's the uncaused cause thing. Okay, so narratives are so when you drop the eraser, right, and we experience it, right, we're not aware of this, and so we have to make it visible. But we have a narrative of space and time, or at least in most of human history, we had a narrative that we weren't aware of, that space and time is flat. It's a stage. Okay. So when we see it fall, we're like, oh, it's falling through space. It's falling through, the motion. Time is keeping track of it. And we like, oh, hey, we have phenomenal truth, right? But the narrative there are different narratives that we then become aware of, which is when the eraser fell, right? It's increasing its speed through time, which means it's increasing its speed through space, which means its speed through time must slow down, because its speed through space time must always be the speed of light. We were never aware of that narrative before, right?
But is it undeniable? Is it undeniable that the eraser fell? Is it undeniable that that happened? Is this
No.
true phenomenally?
No. There's a sense in which you can interpret the narrative of general relativity as that actually I believe something like the stationary object is the thing in free fall. Okay, so right. So I don't want to go into that. That's so technical. Um, but uh, but but because of the math, right? Um, it's not the eraser that's falling. It's everything else accelerating up to it, right? Um, so yeah. Uh,
You're
you,
saying that
you
the
see
math allows for both. The math allows for both, is what you're saying.
Yeah, different math, different choices of uncaused causes, even whether you're aware of the uncaused cause or not, results in different narratives. Yeah.
So this is a narrative truth that the eraser fell. It's not phenomenal truth.
Yeah. Yeah. Because the reason, right, phenomenal truth is just a temporary truth, right? It's only true until we finally realize it's not true. Right? So we thought the Earth is not moving, that was true until we realize it's not true.
But sir, there's little confusion about with the terms of narrative truth and phenomenal truth here. I feel because uh, we ascribe a narrative truth to phenomena predicted by math, and then we realize that the narrative truth was not true because the same phenomena can be predicted by different mathematical routes having their own narratives. But the phenomena itself is an anchor, right? It itself is not something that we disprove.
No, we can disprove it. It's a matter of when, um, uh, uh, because how are narratives overthrown? A phenomenon that was predicted did not conform. Right? You see what I mean? So 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 each narrative truth is actually, a narrative gets overthrown, it gets falsified because of a phenomenon. Yeah, yeah. Um, so, um, yeah, I think you need to clarify more what you're after.
So when the eraser is falling, what is phenomenally true here?
What phenomenally is true is that relative to your chin, it's going further away. Okay, right? But we can interpret that motion in other ways. Let's say, right, which is it's not the thing that's accelerating, but it's the rest of the ground is accelerating up to it, right? Depending on how you interpret the math. Yeah.
Okay, so if let's say I take the example, so what from here on, like this is a direct observation, right? And it is undeniable that it is going away from my chin, relative to me, what I experience in terms of whatever is in my control at least. I can say that what I see happening is the phenomenal truth, right? And now, if I expand my perception through these instruments that you were talking about, I find that there are three ways in which uh, we do these experiments. One is through direct observation, which is just an expansion of what I can see, what I can perhaps manipulate. So, if we take the example of gravitational lensing, now this lensing per se can be a narrative, and the gravitational aspect also can be a narrative overarching. But the fact that we saw that light distorts in a certain uniform fashion, we can ascribe different narratives to it, that space time has been warped, so it has this lensing effect, that refraction is basically happening. But if you go through quantum field theory, gravitons explain it differently. There is some momentum, and basically the processes are such that space time itself has not warped, but light near masses somehow loses its energy or something, and some gravitational redshifts happen. I'm not very sure about how it explains the gravitational lensing, but through quantum field theory also, which is originating perhaps from phenomenal truths of a different scale, you kind of expand it to this scale, and you have different narratives to explain gravitational lensing itself, right? But the fact that did get distorted, and I observed the distortion, that itself is phenomenally true, or that it also is a narrative.
Well, it's phenomenally true until you realize it's not, right? So yeah, we can, as a matter of convenience, just say things are true that we haven't falsified.
So, what is the difference then here in terms of phenomenal truth and narrative truth in
Oh,
this
well, the
case?
thing about phenomenal truth is that does it fall within your sensory perception? That's the only requirement. So it's very easy to define, right? Can you see it? Can you? Is it within your senses? That's what I call phenomenal truth. What I call narrative truth is just things that you will never sense. Okay, you can only guess about that. Okay, that's narrative truth. But even with phenomenal truth, over and over again, we prove phenomenal truth things wrong, right? So they're only truth in it. They're only So it's a matter of definition, right? Something is phenomenally true for me by definition only in the sense of like, does it fall within our sensory perception, right? But with math and with technology, we expand our human perception of phenomenal truth, and so previous things that we thought were phenomenally true are no longer true, right? So, for instance, the Earth is moving. Okay, before we thought it was true that the Earth is not moving. Okay, but through math and through telescopes, we can now falsify the idea that the Earth is not moving. Okay, so we falsified that phenomenal truth. But for the longest time, we did think it was true because it fell within our sensory perception, and our senses, we objectively share that with other people. So other people agree. Yeah, I also think it's not moving. Right? So and I see that it's not moving, and so on and so forth.
So, there is always something that we cannot see to that which we can see, and
Right.
therefore,
And well, again, this shouldn't. What I'm battling against, and in a sense, with you as well, right? No matter how much I say it, we will never let go of this idea that we're somehow psychologically, we can't let go of this idea that we're smart and we're a high life form. Okay. What I was trying to do earlier in this podcast with you was no, we're like 0% creatures, right? It should not be surprising. What I'm saying is that when I point these things out to people, they should give up immediately if they understand that human beings are almost 0% creatures. You're basically you have to prove to me how obvious. First of all, it's obvious that we're almost 0% creatures, right? Because of what we can perceive, right? So your burden, right? And I'm not saying your as in you particularly. I'm just saying you as whoever's watching, who think that we can possess truth. Um, your burden is to explain to me how a life form with almost 0% perception of reality could think that it could ever possess truth.
But I'm just trying to define the truth here, like the scope of truth and what that is.
And the
So, for
scope of truth
example,
is very zero, is very trivial, right? To me, the scope of truth is this: anything that falls within our sensory perception will define it to be phenomenally true. The narrative truth, that doesn't fall within it, and we never have possession of that narrative truth. But now let's go back to phenomenal truth. Phenomenal truth is only true for as long as that lasts. Because with math and with technology, we eventually can show that the things we thought were phenomenally true are not true. And no surprise, because we're 0% creatures, right? Because remember, what's phenomenally true is what we sense, but what we sense so little. So it's very easy for us to be fooled that that's actually true. But
so I do understand that when you say that everything eventually does relate to the uncaused cause, absolutely, I understand, because any theory you come about, any narrative, it will have its own uncaused cause, that there will always, it will always bottom out to something that has not been explained. Those are like the axioms or something, I think. So
yeah,
so I just for intuition's sake, I'm giving these examples just for the sake of building an intuition about it. So let's say this method of detecting a planet in a different star system, which is called the radial velocity method, in which the spectral lines of a star, they kind of have a redshift, the Doppler shift, because of the mutual gravitational pull with the planet that is orbiting it. That need not be a planet; it can be any physical object. But the thing is that experimentally we can only detect this change in the spectral lines, this shifts in the spectral lines, and we infer that there is a physical object there, like a planet, that is causing this have to happen because of intergravitational interaction. And then we are able to predict what that planet, the mass of the planet and certain other aspects, its orbital motion and velocity, everything. But just to get more clarity, is the fact that that planet exists a narrative or phenomenal truth? Because phenomenally, what we perceive is just the redshifts in the spectral lines. We don't perceive the planet. We infer the
yeah,
planet. So is it
yeah, that's
narrative
narrative.
truth that the planet exists?
Yeah, that's narrative, right? And by the way, this is one of the reasons why in astrophysics and in astronomy, you know why you get these weird results where you'll find a star that's older than the age of the universe. You know, astronomy, astrophysics is full of these anomalies where, because of our measurements, we get weird answers. Okay, and that's because our models are so incomplete, and what falls into phenomenal truth for us is so limited. I mean, all we have is a telescope and some color that we see, some frequencies, radio waves and infrared and so on and so forth, right? That's all that falls into our perception. And then we have to create a narrative around it. Is that actually a star that's older than the age of the solar system? Is that a planet that's, wobbling, causing the light to wobble? Is it dark energy? Is it dark matter? Right? That's why we came up with things like dark energy and dark matter. So like, I don't know what it is yet, what the narrative is yet. So I'll give it a placeholder called dark energy.
It's a more uniform redshift, right? It's not like a particular planet having that wobble. Sorry, a particular star
Yeah,
having the wobble.
I'm just talking in general, not necessarily your specific thing. But yeah, if we don't actually see the planet, right? Then yeah, that's part of the narrative, right? Our narrative is that there's a planet that we can't see that would explain what we can see, right? And that happened with the discovery of dwarf planets, and things like that within our own solar system. Um, was that, because of a certain observation that falls within our sensory perception, our narrative is that there must be another planet out there in our solar system. And then we look, and then we find, yeah, there is, right? And when we do look, we see, well, that's part of our sensory. We actually can have a picture of that planet now.
So then it becomes phenomenal truth once we are able
Yeah,
to
it becomes
picture it.
phenomenal.
So the existence of something, it's for example, let's say time. We time is something like we say it's a fourth dimension. right? But do we perceive time? Like we do see things happening, we see things manifesting, processes happening. But is it time that we perceive, or phenomenally we just see things happening? And time is something is a narrative.
Yeah, let's use that example. So phenomenally, we experience past, present, and future. Okay, but the narrative of Einstein's theory of special relativity is that that's not true. Okay, right? So again, it's phenomenally true that I know I was little Phat, and I know in the future I'll be old Phat. Okay, so definitely the past is phenomenally true because I experienced it, right, in my sensory perception, right? So I would categorize that as phenomenally true, okay? But it's not, according to special relativity, it might not be true, okay, right? Because of the idea that to me it's phenomenally true that past Phat doesn't exist anymore. That's why I call it past Phat. But according to special relativity, past Phat still exists for infinitely many observers in the multiverse and universe. Okay? It's just that biologically I can't access past Phat anymore. But biologically I can't access infrared or ultraviolet. But I can produce technology that can do what I can't biologically do. Okay. So maybe I can come up with technology that can access past Phat and prove that's phenomenally true. Okay.
But that's, you're talking about the different narrative of time, right? So for what is phenomenally true and the variations, somebody says that time is something that flows, somebody says that it's like a block universe.
So I'm saying in the future, right? In the future, I could prove that I can I can prove wrong something, right, about time that I experience to be phenomenally true now, right? So suppose my experience that's phenomenally true now is that the past doesn't exist. But in the future, I might be able to prove that that phenomenal truth is wrong, and that's what I meant. Is that what we call phenomenally truth is only true for temporarily. It's not true forever.
But what about the fact that I say time itself? I'm not even defining how it functions, what it is. I'm saying time exists.
Time itself is a narrative truth.
Time itself is a narrative truth.
Yeah.
So that it will be falsified at some point, may or may not be, but it needs to be.
It's already changing like a lot of different ways, right? Time is in the time of Newton to Einstein. It changed even with Einstein, right? It's special relativity time was one way, and general relativity time is a different way.
But why do we need time at all? Like if it's a narrative, I'm saying not the fact that it can the different ways in which we explain time. I'm saying the fact that time itself exists, whatever it may be defined or explained to be. But the existence of time, the existence of a dimension called the fourth dimension.
Yeah, but how it exists, right? How it exists matters because how it exists for us is a kind of phenomenal truth, but the way we experience it can be proven wrong in the future, right? How it exists as a narrative are things that we don't yet experience, but we may be able to test in the future, right? So, um, you know, um, if time, if time is not fundamental, if its existence is not fundamental, but it emerges from information, right? Maybe that particular theory can make some testable predictions, right?
But here we are assuming that time exists, right? For there has to be a reason why we are doing that. Because if it's just a narrative,
And that's points to the uncaused and free parameters.
so time is a free parameter.
In any of your theory, you're making a choice about what your dimensions are, what they mean, what the vacuum is, right? Whether your vacuum is just about space or does it include something about time as well? You're making those choices, right? And that's why its status is to me narrative, right? Because they're just assumptions you're making.
So these dimensions in different theories, these are the dimensions that different theories have. Let's say 4 dimensions, 11 dimensions. These dimensions are free parameters.
Yeah.
So how do we define a dimension? Like when do we summon a dimension?
Dimensions you can define two ways, right? So one way is just a degree of freedom. So, and I can relate it to free parameters and uncaused cause that way. Right? So here's an example. Suppose you and I live in one dimension, right? In one dimension, you and I approach each other like this. We can approach each other or we can withdraw. Okay. We don't ever. It's impossible for us to cross by each other. We can't cross each. Go. You can't go see my back. Okay. You know, you can't go to my back. It's impossible. Now, but my one-dimensional brain can imagine that I somehow can go behind you. Okay. I can imagine that, but it's impossible for me to do. Okay. Now let's imagine two dimensions. Okay, in two dimensions, okay, I can pass by you. It's now possible, but maybe it's hard to do. Okay. But in three dimensions, yeah, I'll just get up and walk. We can just switch places. Okay. Okay, it's hard to do, but now it's easy to do. Okay, so dimensions as degree of freedom, that's related to the free parameter and uncaused causes because you get to choose. So in string theory, why do they go to 11 dimensions or 10? Because it allows them to do things that you can't do with lower dimensions. And so we adjust that free parameter because it's an uncaused cause. Right? We get to choose how many
Of those dimensions are phenomenally true for us, like three dimensions, and perhaps the fourth one as well, time.
the fourth one is time, but that's not enough. We need more dimensions in order to kind of do what we need to do, right? And so that's why we postulate the curled up dimensions and so on, or even a longer fifth dimension, in brain theory, right? Um, so so yeah, so dimensions is kind of in a way a fudge factor, right? If you give yourself more degrees of freedom, more dimensions, you can do more. Things that were impossible are now possible. Things that are possible but difficult are easier. So it's one of the ways that we cheat, basically, to come up with these narratives. Dimensions are also just simply tools, right? So in the Dirac formulation of quantum mechanics, the different dimensions are the different possible states. Okay. And since quantum mechanics is about probability, if I model once, if there's two possible states, I can model each state as one dimension in a two-dimensional um, space, right? And that's neat because if there's a 50% chance of this happening and this happening, then the state vector in this two-dimensional space is right between them, which expresses that this is equally likely to be true, right? And if I have a system in which this is more likely to happen than this, then I can have my state vector as being like this, right? So before I had it right in the middle, but now I can have it more towards this one. So it's a tool, it's a convenience. Defining dimensions in that way captures models really well probability, right? In the Dirac formulation of quantum mechanics. Right? So in the Hilbert space formulation. Right? So the vector formulation of quantum mechanics. So dimensions are a tool that we use to model. They are degrees of freedom. Okay. But by themselves, sometimes they're not enough. You have to define in the space that you're using a particular metric, right? And sometimes it's the metric that's more important. That the way things are measured, distances are measured, and things like that within these dimensions, right? So yeah, you have freedom to choose the number of dimensions, but then you also have freedom to choose the metric. You see all these fudge factors, all these free parameters that we have to generate a whole bunch of narratives. Right? So, And if you're clever, your narratives will work for a while, for 100 years, for 1,000 years. And theories keep on confirming your narrative. But it doesn't mean that's true, because in the 1001th year, we were finally able to do an experiment that falsified the theory, which means it was false the whole time, despite all the confirmation experiments. Okay? So you have to let go of this idea that just because somebody won a Nobel Prize for an experiment that confirms something, which is a big deal, okay, but it's not a big deal in the larger scale of things. Yeah.
This is very interesting, sir, because this kind of alludes to the fact that we have zero perception, yet when we even talk about our own selves, we talk about mental space, our mind space, and these are again narratives that we have derived from the dimensions that we perceive phenomenally, and we are extrapolating that. We're kind of whatever we perceive, we are putting it in those terms, putting it in those scales. So there are phenomena is happening right in front of me, but my own understanding of it is limited by my perception of it. And this perception, even whatever I get through mathematics are relations, but definitely the results are limited in terms of the precision, and that precision you described in terms of the decimal place to which one has a result, and that is infinite. It has an infinite potential to it. Like there is no way we can reach the.
That's the human condition. That's the way that's the way human perceive numbers, is that it has these infinite decimal places.
And the fact that this randomness, arbitrariness of units, that is also based on what we perceive, like length we have a sense of what we know by weight, and therefore we kind of get to an abstract definition of what is mass. If you go to that, you get to Higgs field, which you didn't predict before. You just have it's a narrative route completely different, but that gets to mass. So these things make me think that if I as I said, we are, even when you talk about our own head, even our own thoughts, our own mind, we have this kind of, we are taking from what we perceive and trying to explain other things, and therefore we always land up with an uncaused cause. That is something that cannot be explained. In every way, we try to explain anything, right? Yet, my question then comes about that if there is such a large degree of imprecision and lack of perception in terms of our experience of the outside world and phenomena, do we perceive our own selves independent of this, independent of all these phenomena, including our own thoughts, our own being, our own presence, up to the infinite decimal place of any random and arbitrary parameters that we may assign that to?
I'm not sure I understand it fully. Let me back up a little bit, because you said something interesting at the start of it, and then I'll circle back to try to figure out what you said. You're asking at the end there. You mentioned the Higgs field, so I didn't want to pass by the opportunity, right? Because the Higgs field is a wonderful opportunity to describe the uncaused cause, right? So particles have mass. What caused it? So if you don't give the cause of mass a cause, then things having mass is uncaused. Okay. So now you're free, because it's uncaused, because you're gonna describe the thing that causes mass. The thing that causes mass is now the new uncaused cause. Because it's uncaused, you get to you get to pick what you want, right? So sure, you're gonna find, you're smart enough, you'll find the Higgs field. And so the Higgs field, explains math. But well, what causes the Higgs field? Okay, well, there's something called gauge theory, right? And gauge theory says, there are certain symmetries in physics that if you demand them, it necessitates that you have fields. Okay, right? So then now the new thing that you have to explain is, like, why does physics have these symmetries? So it's always nested, it's always a regress, it's always like, okay, you know, why? Right? What caused it? Because we insist on because we know we have fields, all right? So, uh, and we know that some fields have certain symmetries, and so we can reverse it, which we say, well, if we demand symmetries, then that's going to generate certain fields, right? So anyway, I just want to mention that because you mentioned at the beginning. Now, now, maybe you can rephrase at the end there. You were asking me something. Could you rephrase it one more time?
Yeah, I'll try to, because I'm trying to make a point through that. I wanted to know if my own, I'm saying my right now, I'm saying everybody's, my own sense of being, right, independent of the thought process, because that is again an extrapolation of the three dimensions. There is a mental space, one thought is coming, we don't know whether thoughts are coming or not, that's a projection, right? But my own, independent of even that, my sense of awareness of my presence, that I am my being. Do I experience my own being to the infinitesimal place with respect to any random parameters or units that you might assign to that being, if in terms of scientifically explaining or mathematically arriving at it, whatever they may be in the future, I'm saying, because they're arbitrary, so it doesn't matter. Whatever the units may be, in terms of my own being, of perception of my own self, which is not an interpretation, which is not thoughts coming and going, which is not my identity, which is my presence, my awareness of my presence, is that up to the infinitesimal place precision to any random parameter or units that you may assign to it.
Yeah, I'm not sure I understand the question well enough to answer that. Um,
So for everything that we do perceive, right, there's a limit to it. There is a decimal place beyond which we cannot perceive, because it's kind of how that thing
well,
is.
there's a limit to it in terms of numbers if we can quantify it.
That's because we assign random units, right? We assign units in terms of length, mass, time, energy,
Yeah.
whatever. So these units that we are assigning, so basically that phenomena with respect to these units. And these units are with respect to what we phenomenally or perceive or narratively conjure up, like dimensions, which we do not perceive phenomenally, right? So these units, I'm saying that they may be whatever, because they are arbitrary, whatever they may be. The fact that we are always describing something with respect to them is the problem. The thing itself, which is in what is something that I am, that is me. So me myself, I don't need to describe in terms of any units, because I am that thing is, but we are describing it in terms of certain units. But I myself am, I don't need to describe myself in terms of units. So whatever those units may be for any external investigator, am I myself perceiving myself up to the infinitesimal place of precision that those units may demand ever?
I don't know. I don't know. I'm having trouble conceptually understanding.
Because I found that if every phenomena, everything that we perceive, everything that we see, we will never be able to perceive it entirely. The only way to know something is to become that. If we don't become something, how would we know what it is?
Well, that's the okay. Well, there's two ways to talk about that, right? Which is, um,
And in that sense, just one more thing, because we have this sense of separatedness, we have this sense of separation because of our limited perception. Becoming one with that thing just means that becoming one with the uncaused cause, and that is the only route for you to know something to the infinitesimal place of precision, right?
well, the problem I have with that formulation is that we're not even, you know, when you say becoming one with that thing, you kind of, I think, presupposing that we are one with ourselves. And I don't
Okay.
think we're one with ourselves because to me, I don't think we know ourselves, right? So if we don't know ourselves, and presumably we're better at becoming one with ourselves than with something else, um, I don't think that even if we were to become one with something else, that we would understand it completely. Because if you assume that we're one with ourselves, we don't understand ourselves completely. So becoming one with something doesn't seem to be a path to
I'm not saying understand in terms of being able to express things in other units, arbitrary units. I'm saying that even more fundamentally, we do those things because we have limited perception, right? But those units are relevant only because of that, because they kind of pull things down to our level. But if we completely deny those units, we don't need those units once we are something, right? Once I am myself, I'm not even talking about my thought process, because that is again a projection. I am assigning dimensions to it. There is a thought going, this is happening, that is happening, event, it's eventful. So it is a projection of dimensions that I phenomenally perceive onto what is happening inside my head, to my perception. Separate from that, me being, that perception of the being me, I am, that is up to the infinitesimal place, right? Because I don't have to express myself in any arbitrary units. And to whatever arbitrary units I may express ever from an external point of view, my own perception of that should be up to the infinitesimal place of precision.
I think I'm beginning to understand, right? Um, so you're not talking about perception so much as by definition, you're kind of defining it. You're defining being as something that occupies all of the decimal places. As a definition, I think that's fine as a definition. You're defining being as something that occupies all of the infinite dimensions. Knowledge or perception of being is limited to some decimal place. Yeah, I think that's fine as a definition.
Do you think that this sense of being can be universal, like so that you be everything that you cannot know through your perception?
Well, that's definition. So it's related to everything that we talked about before, right? Because who gets to make the definition? We do, right? So it's uncaused, right? In some way, right? So we can make that definition, and it's only interesting. It's only interesting scientifically if the definition lends itself to testability in the future. Otherwise, it's philosophy, right? Um, so same thing. I can define time to be this or that. I can define time to be an emergent property of information. I can define time to be something warpable by matter and energy, blah, 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 right? But I'm only going to be, it's only interesting scientifically if I can test it. And when I test it, it's interesting if I falsify it. It's interesting if I don't. But if I don't, that still doesn't mean that my narrative of time is going to last. So, sure, you can define being to be that which you have just defined, but it's interesting only as a definition, as a clear definition, right? But what will it do? What will that definition do in terms of providing leverage of how to think in other situations? That's I'm curious about that, right? And I don't know yet. Yeah. By the way, just as an aside, though, uh, this movement of physics towards information, I don't think the narrative is going to last. But think about it. If being is emergent from information, so this is where the thing in Star Trek where they have the thing where you can just say make me a pie and then it just generates a pie in that in the box and you take it out, right? Um, it's always fascinating to me how fiction can be just ahead of where physics actually goes in the future. But uh, so I'm talking about quantum teleportation, right? Quantum teleportation, you're not transporting matter and energy. I mean, that's really hard to do, right? What you're actually teleporting is information, right? So at the basis, the claim in physics is that matter is all the same. Electrons, quarks, it's all the same. You and I, Vedant, are different because of the information that the matter carries. So if I want to quantum teleport me somewhere, all I have to do is collect information and turn something over there in Paris to me. By the way, this is now, you're now testing the mind-body problem, right? Which is before, we haven't had much of a test of the mind ever, but this is a good test, right? Which is, if I reconstitute the body over there by reconstituting the information, does everything else follow? Mind, memory, a sense of humor, or whatever, right? So, um, but so when you say becoming another thing, right, or making another thing, are we just simply putting information onto, is it just really, does it all boil down to information, right? So to know something is to know information. To be something is to acquire that information, right? To become that thing, right? Uh, so it's interesting where physics is going. Yeah.
Right. So that was just kind of I thought of it when we compare René Descartes' quote that I am, I think, therefore I am. So it's like more of an inference of what we mentioned before. For example, inferring a gravitational wave by the time that light takes, right? So we infer that it is because of a ripple. So now, if I'm inferring my own existence by what is happening in front of me, like I think my thought is kind of a sign that I am. There is a difference here because over there I am not the gravitational wave. So it's just a narrative. But here I am me. So I don't need to have a doubt on as if it's a narrative truth that I am claiming. It is me. I may define it, but when I define it again, I am putting certain dimensions and parameters and units to it.
I wonder though. If being can be truly separated from perception, right? Of course, you can separate it theoretically in your mind that being is different than
No, experientially also.
Yeah.
Experientially.
But what I'm saying is that right, the experience of being is perception, no?
Um, because perception, like now that's subjective, right? Because then I'll have to explain the exact feeling of it. So if it's perception, would be, it's difficult to say because your own sense of yourself, is it perception? If you conjure up something, if you try to interpret it, then you have perceived it based on your biases. But until the point you do that, you are. And the perception is something that you are empowered to do.
Yeah, I guess my remarks and questions is really trying to return to the idea of what is it that you can be certain about. I can be certain that you will agree with me that this table is hard. I can be certain about that. But I cannot be certain that under some other kind of context, I wouldn't change my mind about that, right? Uh, and again, historically, we've had plenty of examples of this. Yeah, we can be absolutely certain that everything is circling around the Earth, that the Earth is at the center. We're not moving and everything goes around it. But with more context and more understanding and more math and more technology, not only am I no longer certain about that, I believe it to be false, right? So 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 therefore, I'm like, well, you can't be certain about anything, including the cogito. I think therefore I am, right? You can only be certain to a certain context and a certain time in history, right? So yeah, you and I can be certain that we get thirsty, we get hungry, we can be certain of all those things, and maybe it'll be 10,000 years or 100,000 years before those certainties are tested because of a new kind of context that we can't even anticipate now, right? Uh, so 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 that's really been my message from the beginning. When almost at the very beginning, I said there's narrow truth, there's phenomenal truth, but then there's phenomenon that eventually get even the phenomenal truth in a day, in a week, in 100 years or 1,000 years gets to be proven wrong, right? So we don't have the benefit of seeing the future. We only have the benefit of seeing the past, and the benefit of seeing the past shows that there's been plenty of phenomenal truths that have been proven wrong. And there have been plenty of narrative truths that have been proven wrong. So inductive evidence tells us, and inductive evidence is not certain either, okay? But inductive evidence tells us this will continue in our future.
So, sir, this actually brings me to this point. I was very intrigued by this concept of Planck scale. What is the Planck scale exactly, and does it suggest something about the direction of physics as a field in the future?
So I think it was Planck who noticed that, three fundamental constants, right? The speed of light, which talks about relativity, space-time being the way it is. The gravitational constant, which talks about how matter and energy warp space and time. And Planck's constant, which tells you how reality is quantized, right? These three fundamental constants. He noticed that if you combine them in particular ways, you can get a length, you can get a mass, and you can get a time. And all units are based on some combination of length, time, and mass. Okay, all units are based that way. So by joining them up so that you get these constants, so you get a Planck length and a Planck time and um, a Planck mass, what you end up getting is that, hey, a couple of things. First of all, it seems that the Planck length, mass, and time are the places where all of our theories fail, right? And they fail because they need to be united. Okay, our theories are not united, are not coherent, right? And so at the Planck length, mass, and time, our theories fail because they're not united, right? Because the Planck mass is when a particle of small size has the kind of mass that would form a black hole. So you have something small and yet strong in gravity. So you need quantum gravity, which we don't have. Okay, you have something small, so you need quantum mechanics, but you need gravity because it's a black hole, right? So first the Planck scale demonstrates where our theories fail and where modern new developments in physics have to go. But then these quantities themselves, the Planck mass, the Planck length, and Planck scale, they kind of offer us a potential yardstick. Because you mentioned earlier, why define this to be a meter? It is because we're this size, right? We're this size, a meter is a nice arbitrary length. Okay. Why define 1/1 second as 1/1000? Because we experience time in this way, and that seems like a nice way to define time, but it's arbitrary, right? Why define a kilogram the way it is? Because we weigh this much. Okay. So those things are arbitrary, right? But once you define something like the Planck length scale and mass, you now have a potential yardstick. Let's compare a me, uh, you know, the mass of an electron in kilograms to the Planck mass. If you do that, you will realize compared to the Planck mass, the mass of an electron is very, very light, like 20 orders of magnitude lighter. Okay, uh, you know, um, so and things like yeah, and so things like the density, the Planck density. Okay, the density of our universe is like 100 orders of magnitude less than the Planck density. So this reminds us again of the progression in history where humanity is decentered, right? We used to be at the center. We're not anymore. We thought, protons, neutrons, and electrons are the most important things. Nope, it's only 4% of the universe. The rest of it is dark energy and dark matter, right? So we're continually being displaced, right? And the Planck length, mass, and time is again, if we hold that as the marker, we live in a universe that's so far away from those physics, right? This physics is very interesting. It's like an interesting storm where there's like high energy and quantum foam and black holes, right? Super interesting, right? And we live so far away from that. We live in the boring boonies, uh, where it's very calm, away from the storm. Uh, so we're not where the action is. We're not, uh, we're again displaced. So that the Planck length is interesting for pointing out where we're falling short and where we have to go.
Wonderful, sir. Absolutely wonderful. So, just summing up, how was your experience of this inquiry, the podcast, and is there like a final message that you'd like to give the audience?
The final message that I want to, I think the straight line through is that um, we're very limited as human beings. Okay, so it should be expected that we are not going to possess the truth. Okay, but the truth is worth pursuing because in pursuing it, we experience new things. We experience more wonder, right? Um, so I would say that we should have a sense of pride that we're so smart and we can come up with these new narratives all the time because we have the freedom to. We have the freedom. There's no restriction in our freedom to come up with new stories. And so we should be proud that we can come up with these wonderful new stories because these new stories generate new phenomenal truth for us. But we should also be humble because these narratives are not final. They're always going to be wrong. Um, and then finally, that's sort of more the philosophical, beautiful nature of it. But then finally, the more practical side of this is that since we're talking about truth, you shouldn't just take that as just a philosophical, beautiful thing to talk about. I think in our daily life, every moment, we should bring up what is true. Not in this, I'm not saying bring it up in this philosophical, beautiful way. I mean, in a practical way, because in our own everyday life, we kind of, in a way, ignore truth. It's, so much of this podcast is about focusing on truth, right? But in reality, in my own life and in the lives that I see around me, people are not paying attention to truth at all. Okay, and that's to our disadvantage. That means we're not being the best father we can be, the best human we can be, the best student we can be, the best son we can be, because we're actually not focused on the truth of what it means to be that. Uh, and so I would say that that's my parting word.
Wonderful, sir. Thank you. Thank you so much, sir. This has been absolutely insightful and almost, I'd say, it's enlightening to have to have had this conversation with you. We kind of went over many things and tried to cover a lot of understanding. And I'm so happy that I could talk to you for these things because I don't know anybody else who could do this and help us navigate through reality the way you do. It's absolutely wonderful, and I'm so grateful for this opportunity and your time. Thank you so much, sir, and I wish you all the best and have a great time.
Thank you so much. Thank you for the invitation. It was a lot of fun.
Thanks a lot, sir.